at Service White. Today we will look at law of sines and cosines to solve triangles that are not necessarily right triangles. So let's get started. Okay, I'm going to cover law of sines first, and we will do law of cosines next. Let's have a random triangle, and I will label it like this: capital A, opposite to side A; capital B, opposite to side B; and capital C, opposite to side C, little c. So the capital letters are the angles and the little letters are the lengths of the sides. So you can write sine of A over A is sine of B over B, sine of C over C. You can write this equality, law of sines, also the other way. You can write A over sine A if you feel like it, B over sine B, and C over sine C. Okay, now let's do an example. Let's say they are giving me, I will actually cover this in detail, different types of triangles, but I will do an example where I know some of the angles and the easiest one, and we'll go from there. Let's say we are asked to solve a triangle that's like this. I'm given 30 degrees here, and I'm given 45.25 degrees here, just for fun. I do not know this side. I just put C in there. I do not know this side. And let's go and let's solve this situation here. Let's say this is given. Okay? So I write little a over sine A, and that's going to be little b over sine B. Okay, which one is little a? That's going to be 8, and A opposite of that is going to be sine of 30, and that's going to be B over opposite of that sine of 45.25. And I know everything but little b, so let's pull the little b out. So b, when you crisscross your proportion, remember how you used to do that? So it's going to be b times sine 30, and that is going to be 8 times sine of 45.25. And when I pull the b out, I will get b equals 8 times sine of 45.25 over sine of 30. And I can solve for the b side. So let's go and get our handy dandy calculator. Now it's going to be 8. Oh, make sure that you have it set in the degree mode, and that's the third line in here, degree, and it is set to degree mode. So it's going to be 8 times sine of 45.25 divided by sine of 30. And push enter. That gives you the answer. B is 11.36. If A is given, for example, in meters, your answer is going to be in meters. Okay, and you can actually continue solving that. You can, for example, get the angle C, for example. You can say, well, the angle C is going to be 180 minus 30 minus 45, 25. You can solve for that. So let's go get that. That's going to be 180 minus 30 minus 45.25. That gives me 104.75. All right. You can actually go and solve for another side, for example. I want to have that angle in there. You can say, all right, since I know the C, I can write little c over sine of 104.75. That can be, let's say, a over sine of 30. So let's write these numbers down. So c over sine of 104.75. That's going to be a, which is 8 over sine 30. So when you crisscross that, let's write it down here. You're going to get c times sine 30. And that's going to give you 8 times sine of 104.75. You pull the c out of here. You're going to get 8 times sine of 104.75 over sine of 30. You go get your handy-dandy calculator. So you're going to have 8 times sine of 104.75 divided by sine of 30. Push enter, and I got 15.47. And that's in meters. Okay. Now, let me save this just in case. I will go and show you the law of cosines, and you will end up using law of cosines in certain situations. I'll go in depth for that a little later on, but let me write the law of cosines first. Let's draw a random triangle. Let's A with the little a, B with the little b, and C with the little c. Now, you can write, take one of the sides, you can write c squared equals, that is law of cosines, c squared equals the square of the other two sides, a squared plus b squared, minus 2 times a times b, which is the same of these guys, and that's going to be cosine of what is between those two, which is this angle, C. And actually these two will go together. Look at it. It's easy to memorize this formula. So you have C and the opposite of C. So if you want to write with the same logic, a squared equals, so with that, you're going to have the other two sides, which is b squared plus c squared, minus 2b times c. Remember, they go here together, cosine of opposite of little a, which is going to be big A. Okay, let's write the last one. So I wrote c squared equals a squared equals, so let's write b squared equals, that's going to be the other two sides, which is a squared plus c squared minus 2, and remember how that is, ac cosine of opposite of that, that's going to be b. Alright, now let's apply one of the triangles and try to solve it. Example, let's say I have some like this, 7, I have 9, okay, let's call this C, let's call this A, and I have this one as well, 5. Well, let's write this down, and that's all I know. So the C is going to be opposite of that, and B is going to be opposite of that, and A is going to be opposite of that. Alright, let me write B squared equals, or A squared equals. So I'm going to write this one, or C squared equals. It doesn't matter which one you write. So I'm going to write C squared equals A squared plus B squared minus 2AB cosine of AB, so that's going to cosine of C. Alright? So let's write this down. C squared is 7 squared, A squared is 9 squared, B squared is 5 squared, minus 2, 9, 5, cosine of C. So let's put those numbers down, and I will get 7 squared minus 9 squared minus 5 squared. That takes care of that. Divided by negative 2 times 9 times 5. And that is going to be equal to cosine C. Let's try to get the C. Then it's going to be cosine inverse of 7 squared minus 9 squared minus 5 squared over negative 2 times 9 times 5. So let's get that with my handy dandy calculator. So 7 squared is going to be, make sure you have it in a mode that you recognize. So let's put it in mode of degree. Okay, very good. So I'm going to put cosine inverse of, so I will put 7 squared, which is 49, minus 9 squared, which is 81, minus 5 squared, which is 25, divided by, so 2 times 9 times 5, 2 times 5, that's 10, times 9, that's 90, so it is negative 90, and close the parentheses, and that gives me C of 50.7. Okay, you can go back to cosine law and solve the other sides, or you can use the sine law. Remember how sine law worked? Sine of B over opposite, which is 5, and that is equal to sine of 50.7 over 50.7 was the C over 7. And I can actually solve for the angle B that way, crisscross. So you have sine of B times 7 equals 5 times sine of 50.7. Okay, so that means sine of B is simply 5 times sine of 50.7 divided by 7. And you can go and you can pull that out. So B is going to be sine inverse of 5 times sine of 50.7 over 7. Well, let's go get that. So it's going to be sine inverse of 5 times sine of 50.7 divided by 7, and that is going to give me B of 33.6. And you can get the third angle by subtracting. So the third angle, I have the C and the B, so I need the A, and it's going to be A is going to be 180 minus 33.6 minus 50.7, and that will give me 180 minus 33.6 minus 50.7, and that will give me 95.7 degrees. All right, very good. So we are going to go a little bit in the analysis of different types of scenarios. And here you may say, well, is 33.6 the only angle that gives me sine of that? Actually, it isn't. It can also be 146.4, okay, because remember how sine works. It's going to be 33.6, or since it's also positive on the other side, that can also be 146.4. But the problem with that is, if I pick the 146.4 degree, then I'm not going to be able to get the third angle because it's too large. So I have to stick to the littler angle. So I will go over triangle cases where I know all three sides and I'm using the sine law. And you have to be careful with the sine law because it may end up not a unique solution. So I will have to go over that in particular triangles. But in this case, 146 degrees is too big. So I eliminate that and I end up with 33.6 degrees. So to solve a triangle, you can use the sine law or cosine law, but be careful with it. Please watch the video that has different kinds of triangles so that you take into account those double answers or no answers. Okay? Go watch the other 3 or 4 videos after this.